Good morning. Let's continue chapter 26 about GI system. Last time we talked about large intestine. So let's start this one more time. We said large intestine also is called colon, and it's called large intestine because diameter of this one is larger than small intestine. It's shorter than the small intestine, but it's larger in diameter. The function of large intestine is absorbing water and ions from the contents of the large intestine, and the result of that would be creation of feces. Now, large intestine is going to store feces until you defecate. We said your large intestine is composed of cecum, and then ascending colon, and then transverse colon. On the left side, colon is going to descend, create descending colon, and then it's going to create something like an S shape we call it sigmoid colon, and sigmoid colon is going to turn into rectum. Rectum is going to create anal canal, and then we're going to have anus. In this picture, there is some names that you already know. For instance, you have transverse mesocolon. Remember, this is a mesentery that attaches the transverse colon to the back wall. Here's my sigmoid mesocolon. Again, is a mesentery that attaches your sigmoid colon to the back wall. We said at the beginning of the large intestine or cecum, ileum is going to attach to it, and as a result, we're going to have a valve or sphincter. Here it's called ileocecal valve or sphincter. Attached to the cecum, there is another structure that belongs to the lymphatic system, and that is called appendix. When the particle of food gets stuck into it and cause inflammation, creates what is called appendicitis that needs to be removed by surgery. As you can see, there are two flexures here. One in the right side, when the ascending colon turn into transverse colon, that is called right colic flexure. There's another flexure or angle where the transverse colon turn into descending colon. That is called left colic flexure. Because the right colic flexure is next to the liver, we call this one hepatic flexure. Because left colic flexure is close to the spleen, we call this one splenic flexure as well. Now, let's take a look at the rectum for a second. As you can see, the wall of rectum has three projections. You see two of them here, one here, and there is one on the top that it doesn't show. And these projections are called rectal valve. When feces pass through sigmoid colon and enters the rectum, rectum can expand pretty easily and is used as a storage for feces before defecation. So you don't want these feces to come and drop inside the anal canal. Therefore, we have a bunch of projections inside we call rectal valve that prevent these feces to move faster down and reach to anal canal. As you can see, inside the anal canal, we have some ridges, and those are called anal column. Between these ridges, between this anal column, you have anal sinuses. Anal sinuses has a lot of mucus secreting glands that produce mucus for lubrication. So as a result, when you are defecating, the area would be lubricated, so it's not going to create that much of friction and pain. Also realize the floor of the pelvis, here you can see the floor of pelvis, has a thick muscle, and that is called levator ani. An anal canal is going to go through levator ani to reach to the anus outside. So the anal canal is passing through the floor of the pelvis, and that is called levator ani. There are two sets of sphincters here that controls defecation. One is called internal anal sphincter, and the other one is called external anal sphincter. Internal anal sphincter is the smooth muscle that is involuntary group of muscle. In other words, when the feces gets to the anal canal and push the wall of anal canal, this internal anal sphincter is going to relax on its own. So you feel that you have to defecate. However, you have control over defecation through this external anal sphincter. External anal sphincter is part of the floor of the pelvis. It's a skeletal muscle, and you can voluntarily relax it if you wish to defecate. So let's review the histology of the large intestine. Although this is a topic for the lab, but I'm gonna show you very briefly. Here is gonna be the lumen of the large intestine. Here's where the feces is gonna pass through, or future feces. The function of the large intestine is absorbing water and minerals from this content. As you can see, there's a bunch of opening in the wall of the large intestine that is gonna open to your intestinal gland. Intestinal gland mainly is goblet cells, and as you remember, goblet cells is going to look like white area because it doesn't stain well. So as you can see here, in the case of large intestine, you have numerous number of the goblet cells for lubrication. As the feces passing through the large intestine gets more solid and drier, and as a result you need more lubrication. Again, you can see 4 layers: mucosa, submucosa, muscularis layer, and finally you have your serosa or adventitia. As you can see here, the wall of large intestine create pouches, and these pouches, each of this one like a sac, is called haustrum. Also, as you can see in the wall of large intestine, you have very obvious band that goes along the length of this large intestine. This band is called taenia coli. And also, as you can see, there are some piece of fat hanging from taenia coli. These are lobules of fat hanging from taenia coli, and is called omental appendices. So there are 3 characteristics for large intestine: haustrum, taenia coli, omental appendices. That will be the end of the tube that starts from the mouth and goes to the anus. Now let's talk about the accessory organs attached to this tube, including liver, gallbladder, pancreas, and biliary apparatus. So let's talk about liver. Your liver is composed of 4 lobes. Of course, it is located in the right quadrant of the abdomen. The right lobe, left lobe, caudate, and quadrate. Let's take a look. You're looking at the liver from the front. This is the right lobe, and this is the left lobe. The right and left lobe are separated from each other by a ligament. It's called falciform ligament. At the bottom of this ligament, we have another ligament. It's called round ligament. It's a round ligament. Since we have other round ligaments in the other part of the body, we call this one round ligament of liver. On the top of the liver, of course, this would be your diaphragm. Now, if you grab this edge of the liver and pull it up, of course, you're going to see your gallbladder. Here's my gallbladder right here. This piece between round ligament and the gallbladder, we already mentioned this one before. This piece here, this one, is called quadrate lobe. And if you look at the back of the liver at the bottom, this piece is called caudate lobe. As you can see in this picture, the continuation of the round ligament toward back is called ligamentum venesum. So ligamentum venesum is going to turn into round ligament. So here's a round ligament. When you go toward back, we call it ligamentum venesum. Also, I want you to understand that the inferior vena cava that brings unoxygenated blood to the heart is going to pass behind the liver. So here's your inferior vena cava. Here's my inferior vena cava going behind it. So this piece of the liver between ligamentum venesum and inferior vena cava here, right there, is called caudate lobe. So we have quadrate lobe, which is more in the front. We have caudate lobe, which is more in the back. Quadrate lobe is bound by round ligaments and gallbladder. Caudate lobe is bound by ligamentum venesum and inferior vena cava. Now, I'm sure you learned about hepatic portal vein in your blood vessels in the lab, but let's review this one more time to make sure you understand. So let's take a look at this picture. Here is the wall of the small intestine. The food is going to be inside here, and you absorb this food through this wall. Where this food is going to go? Well, let's magnify this area. This is going to be exactly here. So the food is right here. As you can see, we have a villus here, and blood vessel is going to come in. This is artery. It's going to turn into capillary, and then it's going to turn into vein. And also, you can see there is another vessel here. This one is a lymphatic vessel. We called this one before, and you already know it's called lacteal vessel or lacteal duct. So we have artery. Here's my capillaries. Here's my vein, and this big one is called lacteal vessel or lacteal duct. This is part of lymphatic vessel. So here's my food inside the lumen of a small intestine. Where this food is going to go? Well, the food is going to go through the wall of a small intestine and it's going to get absorbed. Protein and carbohydrate, they're going to get right inside the blood vessels. So that means they're going to enter to the venous circulation. It's going to go this way. Remember, blood is going to come this way and it's going to go this way. So food is going to get inside the venous circulation. It's going to go inside the vein. But fat is going to get inside the lymphatic duct. So protein and carbohydrate and water, all they're going to absorb inside the blood vessels, venous circulation, but large fat is going to get inside the lacteal duct. Okay, for now, let's forget about lacteal duct. When this food, protein, carbohydrates, vitamins, water, they're going to get inside this venous system, where are they going to go? Well, as you can see in this picture, these are all the branches that comes from the small intestine, this one, right? And also all the vein that comes from large intestine, as you can see in this picture, and the blood that comes from the spleen. And you don't see in this picture, but the blood can come from the stomach. All blood that comes from the stomach, from the spleen, from large intestine, from the small intestine, they come together and they're going to drain inside this big one. It's called hepatic portal vein, this big one. Hepatic portal vein is going to go inside the liver, just like this. This is a hepatic portal vein. It's going to go inside the liver. This is vena cava. So it's going behind the liver, it's going to go through. So this hepatic portal vein is going to bring blood to the liver. Why to the liver? Because remember, everything you eat, everything that comes to your body, first is going to go to the liver. What liver does is going to get this food, is going to sort it out, is going to repackage it, is going to detoxify it. If it's not clean, it's going to work on it. It's going to metabolize the food that you eat. Then this blood is going to drain inside the inferior vena cava. So first, this blood with food is going to come inside the liver, as you can see. Hepatocytes, the cell of the liver, is going to work on it. And then this blood is going to leave the liver, as you can see, and is going to drain inside the inferior vena cava. These blood vessels that brings blood from liver and dump it inside the inferior vena cava is called hepatic vein. So we have hepatic portal vein, and then we have hepatic vein. I'm sure they covered this one in the lab for you, but I wanted to explain one more time. In this picture, you can see this is a hepatic portal vein. It's the vein that brings blood to the liver. Also, you can see hepatic artery. This is the vessel that brings oxygen to the liver. And finally, you have gallbladder that is filled by bile. Liver produces bile, and this bile produced by the cells of the liver or hepatocyte is going to come through this hepatic duct and is going to bring bile inside the gallbladder. And I have to mention that your liver is covered by coronary ligament. And the last but not the least is this area that your hepatic artery enters the liver, your hepatic portal vein enters the liver, or your hepatic duct leaves the liver. This structure is called porta hepatis. Porta hepatis composed of hepatic artery, hepatic portal vein, and your hepatic duct. Now, when you look at the liver under microscope, you can see your liver is composed of a bunch of lobules. The hepatocyte arranged in the structure is like a hexagonal with 6 corners. That's why it's called hexagonal. For instance, you can see one corner here, one corner here, one here, one here, one here, and of course, one here that is being removed. So we have 6 corners. That's why we call it hexagonal, just like this one. 1, 2, 3, 4, 5, and 6. So When blood comes inside through the hepatic portal vein and hepatic artery is going to bring blood with oxygen. Hepatic portal vein is going to bring blood with food. So they're going to come and they branch off. They branch off inside the liver, and each branch is going to go to one of this corner of this lobule. So this blood vessel, hepatic portal vein, this blood vessel, hepatic artery, they get inside the liver and they branch off, thousands and thousands of branches. Each branch is going to go to one of these corner of the lobule. And how many corners do we have? We have 6 of them. So here is a picture of one of those corner. So we have branch of hepatic portal vein, we have branch of hepatic artery. Hepatic artery is going to bring oxygen to these cells, so these cells to get oxygen to function, and this hepatic portal vein brings blood with food. So this blood with food and this blood with oxygen, they're going to mix inside the liver. Blood is going to pass by these cells. These cells, they're going to take this blood with food and they're going to work on it. Whatever they have to do, they're going to detoxify it. They're going to package it. They're going to sort it. And after this hepatocyte works on this blood, blood is going to go through this sinusoid and is going to enter to this vein. This vein is located in the center of this lobule. That's why it's called central vein. So this is central vein, this is central vein, this is central vein, and central vein. So remember, again, at each corner you have hepatic artery, hepatic portal vein. The blood is going to come inside the lobule. They're going to get mixed and pass through the sinusoid, and then it's going to drain inside the central vein. This central vein of each lobule, they're going to get together and they create hepatic vein. And hepatic vein finally drain this blood inside the vena cava. Now, let's talk about the bile duct. These cells, or hepatic cells, cells of the liver, they're going to produce bile. This bile is going through a very tiny, small bile duct. It's called bile canaliculi, as you can see here. This bile canaliculi, they're going to join each other, and finally, this bile is going to drain inside the bile ductule. So bile canaliculi is going to get together, create bile ductule. Bile ductule, as you can see, is next to hepatic artery and hepatic portal vein. These three together in each corner create triad. This is called portal triad. So this is a portal triad, portal triad, portal triad. Why is it called triad? Because it's composed of 3 members: hepatic artery, hepatic portal vein, and bile ductule. Bile ductule of each corner is going to join each other and create hepatic ducts. Hepatic ducts, there are 2 of them. One is going to come from the right lobe, one is going to come from the left lobe. So hepatic duct is a result of combining all the bile ductule. They come out from the liver and they join each other and create a common hepatic duct. A common hepatic duct is what you saw in the previous picture, right here. This is a common hepatic duct, this piece. Common hepatic duct is going to leave the liver and then is going to make a turn and is going to create cystic duct. So bile is going to come this way, is going to come this way, is going to get inside the common hepatic duct, and then it's going to move this way up and it's going to come inside the gallbladder. Gallbladder is going to store this bile for the future. When you eat food and the food is going to come inside the small intestine, then you squeeze your gallbladder and the bile is going to move this way up again, is going to come to cystic duct, and then it's going to come inside this duct, which is called common bile duct. So let's do it one more time. Bile is made by hepatocyte. It's going to get inside the bile canaliculi. Bile canaliculi is going to join each other to create bile ductule. Bile ductule is going to join each other to create right and left hepatic duct. Right and left hepatic duct join each other to create common hepatic duct. The bile is going to pass through a common hepatic duct, it's going to come to cystic duct, and it's going to store inside the gallbladder. When you eat food, the gallbladder is going to squeeze, bile is going to move up, it's going to go through the cystic duct, it's going to come this way, and then it's going to come to this common bile duct, and common bile duct is going to bring this bile and drain it inside the small intestine, specifically inside the duodenum. This is your duodenum. Before this one here was your stomach, and after this one would be your jejunum and ileum. So bile is going to drain inside the duodenum. Now you may ask me, while this bile is going to come inside the common hepatic duct, but doesn't continue down, but it's going to go this way up, and it's going to go to inside the gallbladder. Doesn't that much of sense? Well, the answer is, when this common bile duct get to the small intestine, there is a sphincter here, and that sphincter is closed. This sphincter only opens if you want to allow this bile to come inside the duodenum, and that is only when you have food here. So if there is no food inside the duodenum, this sphincter here that we're going to talk about in a few minutes is closed. So therefore, there is no exit for the bile. So as liver produces this bile is going to come, and there is no exit here. So where do you think bile is going to go? Bile is going to go from this duct up, where they can accumulate inside the gallbladder. So there is bile inside this duct, but this sphincter, this exit point, is closed. So there is no room for bile to go this way. So there is only one way to go, and that would be inside the cystic duct and gallbladder. Again, when you eat food, when the food comes inside the duodenum, you will learn in the physiology that you release a hormone, that hormone is going to squeeze your gallbladder, and bile is going to be pushed this way. Since the sphincter is open, now the bile gets inside the duodenum. And that is going to bring us to the pancreas. Pancreas is a mixed organ. In other words, produce hormone and also produce enzyme for digestion. Remember, a part of the pancreas that produce hormone is called islet of Langerhans, or pancreatic islet, this one. And part of the pancreas that produce enzyme is called acinar cell, or acinus. So majority of the pancreas is acinus or acini. There is only less than 1% of pancreas is pancreatic islet, or islet of Langerhans, that produces hormone. Therefore, we say pancreas is a mixed gland. In other words, produces hormone, is endocrine, and produce enzyme, is exocrine. Now, let's focus on the exocrine portion. The acini, they're going to produce enzyme, and this enzyme is going to go through this tiny duct. This pancreatic duct is going to bring enzymes and is going to drain it inside the small intestine, inside the duodenum. Now you realize that this pancreatic duct that brings enzyme to the duodenum is going to join the bile ducts. Do you see that? It's a bile duct, and they join each other and they drain inside the small intestine. This area of the small intestine that this bile duct and pancreatic duct, they're going to join each other, is called hepatopancreatic ampulla. It's a hepatic pancreatic ampulla. The other side, inside the small intestine, you can see there is a small bulgeness like a nipple, and that is called duodenal papilla. In the hepatopancreatic ampulla, there is a sphincter. It's called a sphincter of Oddi. The sphincter of Oddi is the one that is said is closed until food is going to come inside the duodenum. When the food is here, the sphincter of Oddi opens up. The juice of pancreas is going to get inside the duodenum. The bile is going to get inside the duodenum, and they start doing digestion. The pancreas is composed of three pieces: the tail of the pancreas, the body of the pancreas, and the head of the pancreas. This is the head of the pancreas. The juice of pancreas not only contains lots of enzyme, but contains lots of bicarbonate. Why bicarbonate? Because the content of the stomach is very acidic, and when this acid is going to come inside the duodenum, may burn duodenum. Therefore, pancreas produces lots of bicarbonate to neutralize the acid. And that is going to bring us to the end of this discussion. I'm going to come back with a new set of recording for the kidney and reproductive system. Have a good day.